Alright guys, so we got our next video coming here. We're going to begin with the 5 types of forces. So the one that's always there is our FMG, which we call weight. Also we have FN, force of normal. That's our surface force. It's there if it's on a surface. It gives you what you need. We're gonna find that out here in a minute. Then we have FSP, which is spring force. Most scales have springs in them, so that's something else that you'll encounter on the quiz and down here at the very bottom of the review. Then we also have FT, tension, which occurs in a rope, cable, or string. And then finally we have F of F, which is friction. But don't forget, there are 2 types. There's FFS and FFK, this being static, and then turning around, and this would be kinetic. Static would be non-moving friction, and kinetic would be moving friction. Static will always be greater than kinetic. The only kind of friction we'll have on the quiz would be drag, which would be air friction, no surface friction. Newton's law, first law, one word, inertia. So objects at rest have a tendency to stay at rest. Objects in motion have a tendency to stay in motion. Second law, can break that down into F equals ma. You know, every time we sum our forces, we're going to end up setting it equal to 0 or ma. So that's, unbalanced forces gives us acceleration, while balanced forces is equilibrium. Third law, you have your action-reaction pair. The second part of that is equal and opposite. Good idea maybe to draw some force vectors and make them the same length going in different directions, just to make sure you totally get it. So those are Newton's laws. All these Newton's laws will be applied down here. Don't skip this. Define a force. Forces are defined as simply push, pulls. Start doing some force diagrams here. It's kind of a goofy problem, but illustrates force of normal pretty well. A friend has given you a special gift, a box of a massive 10 kilograms with a mystery surprise inside. It's a reward for your great score on your last physics test. The box is resting on a frictionless table. Create a force diagram, complete a summation, solve for the force of normal. So the first thing we want to do is put our mass inside the box. So we put 10 kilograms. Then we want to put in the down arrow. This arrow is always present, FMG. In fact, during this entire thing, this down arrow will remain the same because our weight's not changing, as will be 10 kilograms all the way through. I've set this side as 10. In fact, it's easy to find weight. Mass times gravity, the symbol tells us what to do. So if we say 10 times 9.8, you can see we get 98 newtons. So just kind of keep that in the back of our mind here. I'll put in parentheses. Don't need that for our summation, but it does kind of help us. So first it's just sitting on the table, so there's equal and opposite. Newton's third law comes into play. Surface force perpendicular to the surface, also 98. In terms of our summation, we look at our SWARO. Up is positive, Fn minus Fmg is going to be equal to 0 here as it's balanced. So the force of normal would be 98 because it's the same as the weight. 98 minus 98 equals 0. Continue on. V. Now your friend's pushing down with a force of 40. So he's going to have another force. We'll call it FP. Plus we had our original force, FMG. And so the ground has to push back more. The table pushes back more. It pushes back both those added together. So we had 98. And then we also had FP, our friend, right? Kind of friend destroys your present when he gives it to you. He pushes down on the box with a force of 40. So that means we have an up arrow, Fn. This time it's gotten bigger. It's 138. And that would be 40 plus 98. The math isn't all that difficult, but setting it up at the beginning isn't. And it will get harder as we get better at these. Fn minus the sum of the weight plus the push. Those two things together would then be equal to 0. And the force of normal has now increased to 138. Okay, now we tie a string around the box so the weight hasn't changed, and we lift up. So that would be Ft as it's a string, and it's 40 newtons. We still have our weight, 98, right here. And so the result would be 58 Newton Fn. So Fn is reduced. It wasn't enough to lift it off the table, but it did reduce how much the table pushed. So here at my parentheses kind of changes, take Fn plus Ft, those two together, minus Fmg equals 0. Still balanced, no acceleration yet. So the Fn was decreased like we talked about, and now it's 58. So now we're ready to go ahead and, just a minute, bud, just a minute. Yeah, I'll help you with it in a minute. Head on over there when I finish this, about 5 minutes. So we have Fmg, and then we have an upward force of 100. So it's a little bit more. So we get 100. We'll call that, doesn't really say how, we'll just drop it as Fp. And then we have 98 here. So we say Fp minus Fmg equals ma. So we have 100 minus 98 is equal to 10 times acceleration. So the difference would be just 2 newtons. So A is equal to 2/10, or 0.2, and then acceleration is meters per second squared. So because the force was greater than the weight, the result is acceleration, which is important to understand. Okay, now we're down to the last one, which is the elevator problem, which is the one that kind of gives people problems. So, you know, we got the student, he's standing on the bathroom scale, and the elevator, remember there's a spring in the bathroom scale. We circle what's important, replace that with a box. We have a downward arrow of 70 times 9.8. So finding weight's pretty easy, right? 70 times 9.8 is 686. So Fmg is 686. Then we have an upward force of Fsp, and we don't really know what that is, but we do know that the elevator has a negative 0.5 and the arrow's up. So we have an acceleration, and it's down, and it is negative 0.5 meters per second squared. Negative because it's going against the arrow. And so that means we're stopping on the way up, if you want to think of it that way. You know, as far as the dots go, they're getting closer and closer and closer together here. Therefore showing the acceleration is here. Now the person wants to keep going, and the spring would then be bigger when he stops. And since the spring is bigger, it doesn't push on the dial as much, and the person would appear to weigh less. So we'll go ahead and make our prediction arrow and say that it's going to be less. Now let's do our summation. Sum of forces in the y. We'll say spring minus weight, and that's going to be equal to unbalanced forces is always equal to ma, Newton's second law. So, you know, we want to know what this is, FSP. We know the weight is 686. We know the mass was 70, and the acceleration is negative 0.5. So we're going to have to take 70 times negative 0.5, and we get negative 35. So FSP, think of that as x if you want, minus 686 equals negative 35. So ultimately we add 686 to get FSP by itself. You know, negative 35 plus 686 is 651. So the spring is less. It's 651 rather than what it was if it was at equilibrium, 686 newtons. And then we would also know, and this is going to be important for the quiz, that we're either, you know, when we get this kind of negative acceleration, we're stopping on the way up or we're starting to go down. So we're either stopping on the way up or starting to go down. And that's pretty much it. Hope you do well on the quiz.